What if I told you that you can turn on and off a load, a fan, a heater, or a door, or a system over 13-mile range or 21 kilometers for free, off-grid, without SIM card, without Wi-Fi? Yes, you heard it right. That is possible with LoRa. In this video, I'm going to show you how we can use the Heltec WiFi LoRa 32 module packed inside the Meshnology N32 case with 3000 mAh battery for long-lasting performance and longer transmission and reception time. I'm going to show you the wiring, explain the code, and how to set this up so you can control your device over 13 miles for free. Sounds exciting? If you haven't subscribed to my channel, please hit the subscribe button and let's start with something awesome. This video is part of a 4-video series on Wi-Fi LoRa 32 version 3. In the first video, we learned how to send temperature wirelessly for free over LoRa band up to 13 miles or 20 kilometers. In the second video, we learned how to read up to 150 volts DC and transmit it to 13 miles or up to 20 kilometers for free over LoRa. In the third video, we learned how to turn on and off a relay module remotely over LoRa band at 13 miles or 20 kilometers for free. In the fourth project, we monitor a door using a Hall sensor and LoRa module over 13 miles or 20 kilometers for free. Link to those videos are below this video in the description. Alright, let me walk you through what you're seeing here. This is a Meshnology N32 case, and inside it I've installed the Heltec WiFi LoRa 32 module. It's compact and powerful setup, even better with 3000 mAh rechargeable battery tacked neatly inside it. That means this device is fully portable, neat and perfect with long-range operation. Now, I've got two of these units. One acts as a transmitter and the other as a receiver. On the transmitter side, I'm using built-in user button. I have programmed it so when I press this button, it sends wireless signal over LoRa, no Wi-Fi or cell network needed. Over here, you see the receiver in the red Meshnology N32 case. It's also running on the same 3000 mAh battery inside it, everything clean and self-contained. The batteries can be charged with a built-in charger that is on the module, so you don't have to worry. From USB-C you can connect and charge it. But here is where it gets interesting. Outside the receiver you will notice 3 wires. One of them is connected to GPIO 4, which is our signal pin. The other 2 are connected to ground and 3.3 volts. These wires are connected directly to the relay. The relay can control things like a fan, pump, or even garage door. So just so things stay clear, I'm holding this bare Heltec WiFi LoRa 32 board in my hand. That's the exact board that is inside these Meshnology cases, so you can see what's really doing work behind the scene. This setup is simple, powerful, and lets you wirelessly control real devices from miles away, all without complexity of the internet. Right now the relay is on. Now I've connected the buzzer instead of relay with a transistor. I'm going to show you the circuit. When I turn it on, the buzzer will turn on. I'm holding it. So it's toggle. And you can turn it off. To extend the range, you can get this 5 dB milli high gain antenna for the transmitter and the receiver, so the sensitivity of the receiver is increased, and the transmission power will be propagated better with this antenna. To purchase any of the items that you see on the screen, the links will be below the video in the description. So Heltec WiFi LoRa 32 is integrated with LoRa, with Wi-Fi and Bluetooth all in this module. When you get N32 package from Meshnology, this is the package that is sold on Meshnology.com or on Amazon. I will provide you the link. And it can fit also the 3000 milliampere hour battery which is sold. So the ESP, the LoRa 32 and the battery will fit perfectly. This module is inside this package at the moment that you see, and the 3000 milliampere hour battery from Meshnology also fits. This is very important because this is very important with high capacity battery. You can have longer transmission time and longer reception time if you have it in any product, so it will be on any package. And this is our transmitter which will transmit. We are going to use this user push key to control the relay. And let's say we have two devices and the relay is off. When you press this button, the relay is on and it will transmit the signal. Then this will receive the signal and will be ready to trigger pin 4. And the receiver is connected to the relay, which I'm going to show you all the wiring, and you will connect your load to the relay, which I'm going to also show you the wiring. To increase the gain, instead of this antenna, you can use high gain antenna, so increase the transmission power and range. So this is the size for the high gain antenna. The link to purchase all these components are below this video in the description. Meshnology, when you come to Meshnology.com, I've reviewed for this N30, but in this video we're going to do the review of this N32 series. You can buy it with a battery, with an antenna, with all these packages. The link will be provided. You can purchase it from Meshnology.com or from Amazon. The links will be provided. You can buy the package. You can buy a package with a microcontroller and LoRa and 3000 milliampere hour battery, extra antenna, and the shell. You can get the red one, 2 package, 1 package, whichever package you prefer. The links will be provided. You can purchase the package green, red from Amazon, or with a battery. Any package you want, 1 or 2 packages are all available. The links will be in the description below this video. Let's have a look at the case. We see from these 2 buttons and this is the package of 2 batteries I purchased. This is a package from Amazon. It comes with a charger, and each battery is 3000 milliampere hour. 1 cell. This is 3.7 volts and 11.11 watt hour. The module first connect the cable that comes with the module, and if I turn it around you see it. Then we will insert our remove the nut, connector here. This is inserted fully and you have that much room out. Attach this piece of ring. Let's see how much room we have. Yeah, so insert the spring washer. Round and squared holes, the same as these two. So round will go with the round. Use these two screws to attach them at these corners. Connect the antenna, because without the antenna, do not connect the battery. Our receiver is now packed and ready. Let's test the cable connector to see if it charges. Now there is a problem. If you want to disconnect the battery, the power is already on. You cannot do that. It might damage the transmitter. So what you do is open everything, disconnect the battery, and then remove the antenna. Otherwise, the LoRa module might get damaged. And here is the wiring for the relay. In this example, I have placed a motor and battery for the motor. So this is a motor, this is a relay, this is our Heltec WiFi LoRa 32 module. This portion is totally separate from our circuit because there is no electrical connection between the circuit. So this portion acts like a switch. One wire is connected to the motor. The other wire, if you connect it directly to the motor will be turned on. But we have connected it to this point. When we turn on the relay, it comes like this. It goes and the motor will turn on. So this is example of a motor, but you can put garage door, I don't know, fan, whatever, AC load, DC load. If it is AC, you will connect this to AC. Now we come to this side. This is signal pin, the left side. In this case, it shows 7. but when you put it on the case, actually the pin 7 will not be available because underneath is something. So you might connect it to pin 4 and change the pin number in the code to be 7 or 4, whichever you connect. Then from the ground, we have one wire connected to the right side, which is labeled negative. Make sure to read it. If it is negative, connected there. The middle pin is depending on the relay. If it's 5 volts, you need 5 volts. But I tested it. It works, but it's not reliable with 3.3 volts. From the second pin, which is 3.3 volts, you connect a wire here, and then you can put a booster here, so the 3.3 volt will get boosted and you will have 5 volts connected there. But if you want to work with 3.3 volts, just continue like this. And this, if you want to connect a boost converter, this is a boost converter. The ground is, this is N positive and then N negative. This is N negative, and 3.3 volt is connected to N positive. This gets it. So from this screw, you can set the voltage. This is a multi-turn potentiometer, so you have to turn it 10 to 15 times before you see the change. And the output will be from here, so 5 volts. So you rotate it, use a multimeter until you see 5 volts, and connect it. We don't need the negative because this negative is common and it's the same wire. So one negative or ground is enough. And here's the wiring for the buzzer. We have two N3222. This is an NPN transistor. So you insert it on the breadboard. This face is flat where the mark and model of the transistor is written. So the left pin is from this wire, it's connected to the ground. The right pin is connected to the negative of buzzer, the shorter pin of the buzzer. From 3.3 volts, you connect a wire to the positive of the buzzer. Now, pin 4 is connected to a point where we have 1 kilo ohm resistor connected to the middle. That's the base of the transistor. I started using a 2N2222 transistor, connected the black wire on the emitter, which is the left pin, and then on the middle pin I've connected a 1 kilo ohm resistor. I have soldered it, and the other side of resistor is connected to this purple wire. The right pin is collector, it is not connected to anything. Then, as you can see here, I have the buzzer is such that the left pin is positive, the right pin is negative. I have soldered the right pin or negative pin of the buzzer to the transistor. That's a collector. And I have inserted heat shrink sleeves to prevent it from short circuit. And now we have only left pin of the buzzer left, which I've connected to the red wire, which goes to 3.3 volts. This buzzer is actually 5 volts. I've tested it and it works also with 3.3 volts. So this will work for any other project that you have. This is a complete project. I put also another heat shrink here, so it's protecting all the components and also holding it tight. So this goes to 3.3 volts. This is ground, and this goes to the resistor or to our program to pin GPIO4. And here is my voltage source from these two, 3.3 volts. And after putting it all together, this is how it looks like. So I can connect it from outside the case. Preparing it fully, let's test it. Red is 3.3 volts, black is ground, and if I connect this pin to the 3.3 volt, it should make buzz. So the transistor is working and the circuit is ready to be tested. Let's create some hole here for the wires. I'm going to connect these 3 wires. This will go to 3.3 volts ground, and this will go to pin 4, and they will exit like this. Now I've placed it, and I'm going to close it down. So let me turn on the transmitter. Now it receives the signal. In order to work with Heltec WiFi LoRa 32 board, you need to install certain software on your Arduino IDE. First, we need to install the ESP32 boards, which is needed for any ESP32 board. Open your Arduino IDE. You can get it from arduino.cc. This is a free software. Go click here, boards, and then type ESP32. Here it says ESP32 by Espressif, and you will see here install button like that. Click on the install, and that will be done. Then we need to install certain software for Heltec. First, we will install ESP32 package. I will provide you this URL here, the JSON URL, which you can get it from Heltec documentation page under the ESP32 series. You right click and copy it. I will provide you the link. On Arduino IDE, click File, Preferences. This area is for additional boards. Click to open it so we can see there is nothing. If you see another line, just at the end of the line, click and go down, and then right click and paste, and click OK, and click OK. Wait for this to complete. Click on boards and type Heltec ESP32. You will see it here, and this button would be install. Click on it to install it. Then we need to install ESP32 extended library from Heltec. Now click on library. This was board and this is library. Click on it and type Heltec ESP32. And you will see here it says Heltec ESP32 dev boards. You see it says remove. If you have not installed it, you will see install button. Click and install it. Then we need Adafruit GFX library for the display. Come here, click on library and type Adafruit GFX library. And here the first one, Adafruit GFX library. Click install. It says it needs dependencies. Click install all. Wait for this to complete. Then we need to install the Robojax Heltec LoRa 32 zip library. This is needed for OLED and reading voltage. I will provide you the link from the description. Download and save that .zip file in your computer somewhere. Then click on Sketch, include library, add .zip library. Browse to where you saved it, find it, click select, and then click open. All the libraries and files that were needed have been installed. To check if the Robojax Heltec library have been installed, click on File, Example, scroll down until you see Robojax Heltec LoRa 32, and these files are there. make sure the board is selected. If not, click here and select board and type here V3. You will see Heltec WiFi LoRa 32 V3. You see another kit is there. This is without LoRa, so select that, and then you should see the port. Select and click OK. Now let's open the transmitter code. Click on File, Examples, scroll down to Robojax Heltec LoRa 32 and come here, Relay Secure TX Simple. Click to open it. This is the code. This line is for debugging. Set it to false, but if you want to turn it on, then on the serial monitor it will print a lot of information, so keep it as false. This pin is connected to the user pin. I'm using the user pin, but if you want to use other pin, change it. Otherwise, do not change. These are internal pins that are defined. Do not change them. This is the text that is shown on the screen. See here, relay on and off, and also here RX, which will change to TX. So you can change them accordingly if you want, but I will suggest not to touch them. This is your security key, which is shared between transmitter and receiver, and this is your secret. Otherwise, your communication is not secure, and your device can be turned on with somebody else's signal. This is the LoRa frequency for the module that I use, and here is the power. For lab purpose, I'm using 2, which is the minimum, but you can go up to 20 if you need to have longer range. For the test that I do for the longer range, I'm going to set it to 20. Once everything is set up, just click here to upload it. Let's have a look at the transmitter toggle. Click on File, Examples, scroll down to Robojax Heltec LoRa 32, and here Relay Secure TX Toggle. Everything is the same, except this will just toggle the relay when you press it. Now let me show you the receiver code. Click on File, Examples, Robojax Heltec LoRa 32, and Relay Secure RX. Now the debug is the same. If you want to see the debugging, this pin is pin number 4 that we are controlling our relay. You can change it if you wish. And these are the text that are displayed on the screen. When it is not toggled here, as you can see, we have 3000 milliseconds. Every time you press it or the relay is on, it takes 3 seconds. So you can change it to 1000 milliseconds or 1 second. The same security key must be shared with the transmitter and receiver. Here we set the frequency for the LoRa band. Because TX or transmitter is not used, this has no effect. You don't need to. Now let me demonstrate controlling the relay. At the moment, the program that we have on this is to push and hold so the relay is on. Let's say you want to open a garage door or fan or whatever you have, but you don't want to toggle it. When you release your hand, it can open. Let's say you want to open a door or something. So I'm holding it. It's on, and on arrived, and you can see the light is on, and when I release it, it turns off. I am turning off the light so you can see it better. Now let's hold it on and receive. It's on. Now it will receive off and it will be turned on. And here is a code where when you press a button, let's say I press it and it is now on is transmitted, and the relay is on and it's holding, and it is holding, and you don't need to hold your finger as long as you wish. And then when you want it to turn off, press and change this to off. It's receiving it and turning the relay off. Now let me demonstrate the buzzer. The buzzer is connected to the same wires to the GPIO4, ground and 3.3 volts. And as I shown you on the wiring, there is a 2N3222 transistor, because you cannot connect this buzzer because it needs around 20 milliampere, and it will damage the microcontrollers, the ESP32. So this project right now is toggle. When I press this, I've added a delay here, few milliseconds, and when it's turned on, the signal goes and it checks it. Now the buzzer is on. If I press and hold it again to turn this off, and the off will be transmitted and it will be turned off. So this is just for toggling. Now this is ready. When I press it and hold it on, the on is now arrived here, and the buzzer is on. But I have to keep holding my hand, because in some application you need to hold it. And when I release it, it turns off, and the off is being transmitted, and it is received here, and it is turned on. I've added the delay in the program. Now you saw the test in the lab. We were able to turn on and off a relay. You will be wondering how this will work with a long range. I have used the same Heltec WiFi LoRa 32 module with Meshnology N32 and the 3000 mAh battery, exact setup, while transmitting the voltage. The process, specification and setup is exactly the same. Instead of sending on and off signal, we were sending voltage. So in order to avoid repeating, I'm going to show you the original video for sending the voltage so you know how it works. Now to get started with the range test, I'm setting this power to 20. When I work here in the lab, it will be 2 because we don't need, that's the lowest. And I can go 21, but I'm going with 20 to test it. For the transmitter code, you must select your security key, which must matches with your receiver. You use the same code, you can change it, and this is the frequency that we set. So these two must match, and then set the power that you want. Here, the test is performed in this area on the lake because there is no obstacle on the path and it's direct line of sight. We place our transmitter here, and it's almost about 10 meters above the water level. And as you can see, there is no obstacle on the path because we avoided all this, and it's about 13.04 mile or 20.98 kilometers, which is almost 21 kilometers. Let me show you my setup for range test. I've placed here a camera. Transmitter is installed on a tripod, and it's connected via these wires down to the battery, where we can reach up to 30 volts of the voltage. I've set this up by the lake, and we are transmitting it about 5 to 10 miles or even more. I'm going to see how far this can transmit. We're going to transmit the signal on the other side, and we're going to see the voltage that's being transmitted. receiving it on this receiver, and I'm going to show you on the Google map to see how far we are. I've left the transmitter there and then walking towards my car to drive to the further destination so we can receive the signal. I'm 13 miles, which is about 20 kilometers away from the transmitter. Here my map is showing it. I hope you can see it because it's a bright sun and the voltage is now on the screen. So I've called already my friend on the other side. So I'm gonna ask my friend to change the voltage. Please change the voltage.
Okay.
Okay, so as you can see now we see about 9.71 volt and 13 miles. Amazing. This is unbelievable. So we are 20 kilometers away from that direction where the antenna is pointing, and we are receiving signal. So for conclusion, I would say if you want off-grid communication, sending and receiving information, monitoring devices or something, Wi-Fi LoRa 32 is the best option, very cheap. The link to purchase any of these components are below the video in the description. I have a resources page with all the photo, wiring diagram, everything, and the link will be below this video. If you purchase any product from those links, I'll get some commission. It will help me as well. Thank you.